A ship S is 10.5 kilometers from P and sailing to R on a bearing of 56 degrees. Presently, the ship is 8.4 kilometers due south of Q. Q is due east of P and also due west of R. And so here we have a diagram, and our goal is to calculate the distance PQ. Notice that we have PQ right here. And what we actually have is a right angle triangle. So notice that PQ is one of the legs of this right angle triangle. Now, what we're gonna do is we're gonna label this triangle. So we're gonna call this side, we're gonna call this C, right? And we call that C because it is opposite the right angle, and that's the hypotenuse. So C is the hypotenuse. We're gonna call this A, all right? And the side that is missing, which you're trying to find, we're gonna call that B, all right? And this is important to label it because we are going to be using the Pythagoras theorem. And so here the Pythagoras theorem says that C squared is equal to A squared plus B squared. Now here in this question, C is 10.5. So C is 10.5. A is 8.4. And so we have 10.5 squared is equal to 8.4 squared plus B squared. Next, we say 10.5 squared, that is 110.25. And 8.4 squared is 70.56. What we're gonna do is we're gonna send the 70.56 over the equal sign. When we do that, we have 110.25 minus 70.56 is equal to B squared. When we subtract them, we have 39.69 is equal to B squared. Now we need to take the square root of both sides because we want to get rid of this power of 2. And so when we do that, we take the square root of both sides. We cancel this with that. And so we are left with B is equal to 6.3. That is what B is equal to. B is equal to 6.3. And so that means that the distance PQ is 6.3. All right, so the distance PQ is 6.3, and that's the answer to this question. Let's move on to the next one. Here, they want us to calculate the angle PSQ, and what we really want to zero in is on angle S. So we have PSQ, and notice here I have theta labeled. That's the angle that we want to find. We have all three sides of the right angle triangle, and so that's good. Let's label this triangle. So this side that is opposite the right angle is called the hypotenuse. The side that is opposite the given angle is the side that is opposite theta or opposite the given angle is the opposite side, and the remaining side is the adjacent side. So we have the hypotenuse, the opposite, and the adjacent. Since we have all three sides, we can use any one of the three trig ratios, but I want to use the trig ratio that uses the sides that are given. All right, so I want to use the sides that are given. So the hypotenuse is given and the adjacent is given. So I'm gonna use tangent. So let's use tangent, and no, the adjacent is given and the hypotenuse is given. So we must use not tangent. I'm sorry. We must use cosine. All right. So notice here, cosine uses the adjacent. All right. And cosine uses the hypotenuse. All right, see right there. So we want to use the hypotenuse and we want to use the adjacent. Now, like I said, we could use any one of these three trig ratios since all three sides are given. But I want to use the trig ratio that uses the sides that are given. So here we have 10.5 is given and 8.4 is given. And so I want to use the trig ratio that uses the given sides, not the side that we had defined, which was 6.3. Why, you may ask? In general, it is a safer route. It is safer to use the side lengths that were given, especially if you don't have to use the side that you found, right? So you just use the sides that were given to you, and it's a safer route, all right, in general. So we're going to use cosine because we have the adjacent side that was given and the hypotenuse that was given. And so let's substitute. So we have the adjacent is 8.4 and the hypotenuse is 10.5. So we have cosine of theta is equal to 8.4 all over 10.5. We're going to take cosine, we're gonna apply cosine inverse to both sides of this equation. And we're doing this because we wanna get rid of, what we're doing this because we wanna find out what theta is. And so we wanna isolate theta. And so we take the cosine inverse of both sides, because when we do that, we're able now to cancel this cosine with this cos. And so we are left with theta is equal to cosine inverse of 8.5 all over 10.4. Cosine inverse of 8.5 over 10.4 is 36.86989765. And so that's the answer. But what I'm going to do here is I'm going to round to the, I'm going to write this correct to the, I'm going to write this correct to two decimal places. And that's what we have here. Notice that this is 9. Once it's 5 or more, you can round up. And so this 6 turns into 7, and we do not write the rest of the numbers. So we have 36.87, and that's the angle PSQ. The angle PSQ correct to two decimal places is 36.87. Next, the question wants us to calculate the bearing of P from S. So we want the bearing of P from S. And so notice that we have S here and we have P here, right? So we have S here and we have P here. Now they say from S, which means that we must start at S, and we must draw our north, right? Draw our north. So this is our north, right? And then we must go in this direction until we reach P. Until we reach the line that is associated with P, right? Which is the same line, all right? So you start at S, you draw your north, and you go in this direction until you reach this line that is associated with P, all right? And so what is the bearing? Well, the bearing, right, is the size of this particular angle right here, right? The angle that is represented in red, right? So we have to figure out the length, or we have to figure out the measure of this angle right there, right? So what is the measure of this angle right there? Now, what we do know is we know that this angle right here, angle S, we know that this is 36.87 because we just figured that out in the previous question. If we want to figure out what is the measurement of this angle in red, well, we just have to remember that angles, we just have to remember that when you have a full revolution, right? When you have a full complete revolution, right? It's 360 degrees. And so in order for us to figure out what is the red part, what we have to do is we have to subtract. We have to take 360 and subtract it with 36.87. And when we subtract this, right? When we remove this particular angle, what we have left is the angle in red, all right? And so when we remove 36.87 from 360, because because a complete revolution or angles in a circle add up to 180. And so once you have a complete revolution, you know that's 360 degrees, but we don't want the complete revolution. We just want a portion of it. And so we take 360 and we subtract it with 36.87. When we do that, we get 323.13 degrees, and that's the bearing of P from S. Next, the question wants us to calculate the distance SR. So this is the distance SR right here, right? This is the distance SR. Now, SR is one of the sides of this right angle triangle. That's SR, okay? And so what we're gonna do here is we are going to label our sides. So this side, the side that is opposite the angle is the opposite side. The side that is opposite the right angle is the hypotenuse, and the remaining side is the adjacent. So this is the adjacent. Now, what are we trying to find? Well, we're trying to find the hypotenuse, all right? So we're trying to find what is the hypotenuse, all right? And we have the adjacent. And so that's very important. We're trying to find the hypotenuse, SR, but we have the adjacent, okay? And we also have the given angle. So we have to focus on the adjacent and the hypotenuse. So which trig ratio deals with the adjacent and the hypotenuse? Well, that's cosine of theta again. So we're going to use cosine of theta. And so what is the adjacent? The adjacent is 8.4. What is the hypotenuse? Well, we don't know what the hypotenuse is. That is exactly what we're trying to find. So that means that we have to put x here because it's the missing side. And we know that theta is 56 because theta is the angle. And so what we're gonna do here is we're gonna put cosine. What we're gonna do here is we're gonna put the cosine of 56. We're gonna put that over 1. And so we have cosine of 56, we put it over 1, and we set that equal to 8.4 over x. And we did that because we want to cross multiply. And so we cross multiply right here. And so we have x multiplied by cosine of 56, and we have 1 multiplied by 8.4. And so what we do here is we have x times cosine of 56 is equal to 8.4. And so we have to divide both sides. We have to divide both sides by cosine of 56. And when we do that, we can cancel out this cosine of 56 with this cosine of 56. And we are left with x is equal to 8.4 divided by cosine of 56. And when you do 8.4 divided by cosine of 56, what you get is you get x is equal to 15.02164986. And that's our answer. But what we want to do is we want to express this answer correct to 2 decimal places. Now this one here, once it's 5 or less, once you have this number being less than 5, that means that you cannot round up. And so that means that we leave it as such. So it's just gonna be 15.02, and we remove all of the numbers in the back here. And so that means that the distance SR correct to 2 decimal places is 15.02. And that's the answer to this question.